2020 paper 2 question 2 is a circle question. A is the center. We have B 5, 8. We're given the equation of the center of the circle, which we'll rewrite as x minus 2 to be squared to give me my x squared and my minus 4x. And we're going to have y plus 1 to be squared to give me my y squared and my 1y. And we need to balance off this equation. We have a plus 4 minus 2 squared. We have a plus 1. So we have plus 5, but we want minus 4. So I have to take away 9 from this left-hand side. So I bring it to the right and write 9. So we can see here that the center is, you just take these numbers and change the sign if you've been following what we've been doing before. 2 minus 1. And the radius is the square root of the right-hand side. This is r squared. So the radius is 3. So we have a starting point here. Before we do anything, we have a radius of 3, and we're told the line L is a tangent to C at the point T, and we're asked to find BT. So we're asked to find this line along here. So we have the radius. So I just need to get AB here, and we can use Pythagoras. So the point A is 2 minus 1. So the length AB, the square root of the change in x to be squared. So 2 and 5, the change in x is 3 squared, plus the change in y, minus 1 to 8, so that's a 9 to be squared. So that's the square root of 81 plus 9, which is the square root of 90. So that's the length of AB. That does simplify to be 3 root 10. If you want to write it in simpler form, you can leave it as square root of 90 actually for now, because you can see here, we're going to get BT. Is using Pythagoras. Here's my right angle, so my hypotenuse, just be careful which one, is the square root 90. So this is a takeaway, the square root of 90 to be squared, which is obviously 90. Take away the radius to be squared, which was 3. So we're going to have 90 minus 9, so the square root of 81. This works out nice and evenly, so it's equal to 9 units BT. And second part of this question, two circles have their centers on the x-axis and each circle has a radius of 5. The point 1, 4 lies on each circle. Find the equation of C1 and the equation of C2. Okay, so the point 1, 4 is on each circle, so let's do a little coordinate diagram here. So the point 1, 4, let's say it's here, and we'll call this the point A. Now, there's the center of this circle, so A is on the outside of the circle because it touches. So let's just assume that this is the radius. If we go straight down to the x-axis, we're only going down 4 units. So if we put the compass on A, or we put the compass on the center, and it'll be 5 units to go through A, so that has to be 5. So we can actually create a right angle triangle here, and we know the center has to be, if we take this point 0, 1, the center has to be somewhere in that direction to make it longer than 5. It has to be somewhere in that direction to make it longer than 5. There's only going to be 2 exact points where it's 5, and the centers are on the x-axis, so this also has to be 5 out here. Now they're supposed to be symmetrical, so what can we say here? Well, if I get rid of these arrows, what point have we got here? This is the point 0, 1, and that's 4 units to the point 1, 4. So if I take this triangle, and they're both the same triangle, I have a radius of 5 and a height of 4, so the distance from 0, 1 from here to here is 3, based on our knowledge of right angle triangles. So now what I can do is I can get this point here, which is one of the centers. If I add 3 to 1, 0, not 1, 0, not 0, 1, 1, 0, I'm going to get to 4, 0. So this point is 4, 0. That's one of the centers. And if I go in this direction and I take away 3, I'm going to go from 1 to minus 2, minus 2, 0. So I have my 2 centers. So the equation of this circle, x minus the x coordinate of the center to be squared plus y minus the y coordinate of the center to be squared. You could just write y squared equals the radius to be squared, which is 25. And the equation of this one is x minus minus 2 to be squared plus y squared. You can write these either way, is equal to 25.